All right, you are welcome back. Now we are now in section 6.7, section 6.7, which deals with the application of the matrices we have been talking about, and especially the inverse matrix, the inverses. Okay, this is called Leontief input-output analysis. Input-output analysis. Leontief input-output analysis. So this input-output matrices was developed or were developed by Wassily Leontief. Okay. These input and output matrices codify the supply and demand interrelationship. Okay, supply and demand interrelationship that exists among the various sectors of an economy during some time period. Okay, so the phrase input and output is used because the matrices shows the values of output of each industry that are sold as input to each industry, okay, and for final use by consumers. Okay, so we have some values that are input to another sector or they are output to another sector. Okay, so that is what this matrices is talking about. So Leontief won the 1973 Nobel Prize in Economic Science for the development of this input-output method and its application to economic problems. Okay, so as we are going to be seeing very soon, but if we have this given equation, we have seen something similar before in the previous video. Please make sure you watch it if you have not watched that video. So if we have something like this equals to b, we are looking for our x. So x will now become the inverse of a multiplied by b. The inverse of a multiplied by b. So we find inverse and then we multiply by b. We did that in the previous video. So in order to find x here, we say x will now become the inverse of this one multiplied by d. The inverse of that multiplied by d. Our x is the production. So we want to find production, then we now find that inverse of I minus a, then we multiply by d. Okay. Or we can solve it by an augmented matrix. Also in one of the previous videos, we also talked about that. Okay, so if we still have a x equals to b, you can solve this by putting a alongside with b, and then you reduce this matrix. And then whatever you get, you are going to now get your x from it. Okay, either you solve it this way or you solve it this way. Okay, you are still going to get the same thing. Either you solve it this way or you solve it this way by finding matrix the inverse matrix first. And in finding the inverse matrix, you put the matrix A side by side with an identity. And you reduce this A to an identity. Then whatever you have on this side is an inverse. Okay. All right. So you can also solve it that way. All right. So please take note of the method you are going to be asked to solve. So we refer to A in our discussion as Leontief. We are going to call it, though not a standard nomenclature, but we call the matrix A Leontief matrix. Why the matrix I minus A is the coefficient matrix. We are going to be calling that the coefficient matrix. Okay. Of whose system, of the system whose solution provide the production X, needed to satisfy the external demand D. So our D is external demand, our X is the production, our A is Leontief matrix, our I minus A is the coefficient matrix. Okay, things will be clearer now as we take an example. Okay, so let's look at this example. We are going to be given the input-output matrix of a sector, okay, like this. So, and you can see that there are sector 1, 2, and 3, others. Okay, but only sector 1, 2, and 3 has external demand. So we have external demand for sector 1 is 36, for sector 2 is 156, for sector 3 is 240. Okay, so sector 1 serve as an output to itself, as an output to sector 2, output to sector 3, and then sector 2 also serve as an output to sector 1, and this to itself, and this to sector 3. And sector 3 serve as output to sector 1, this to sector 2, and this to itself. Okay, so now we want to change the external demand to 77 for sector 1, 154 for sector 2. This actually reduced, this increases, this reduces, and this also reduces for sector 3. So we now want to find the production necessary to satisfy this new demand. The old demand that was there, for the old demand is 36, 156, and 240. That is the old demand. I can call it old. Okay. Why the new demand? The new demand is now 77, 154, 231. So that is the new demand. We want to find the production X for this new demand. Okay, we want to find the production X for this new demand. Okay, now the first thing is, given this table, the entries are in millions. They are millions. They are millions. Okay, given this table, the first thing to do is to find out our Leontief matrix A. To find our Leontief matrix A. That is the first thing to do. In order to find out our Leontief matrix A, please look at this, make sure you understand. In order to find our Leontief matrix A, we are only dealing with this sector that has external demand and is a square matrix. It's a square matrix for sector 1, sector 2, sector 3, sector 1, sector 2, sector 3. Okay, it's a square matrix. Okay, we are only dealing with this. But in order to find A, we are not just going to pick this. First, we need to sum up the columns. Sum up the columns. So find the sum of each columns. Find the sum of each column. That is the first thing to do. We need to find the sum of each columns. To find the sum of each columns. Okay, to find the sum of each column, we need to sum up this. Okay, to sum up this should give us 600. Summing up this should give us 360. Summing up this should give us 480. Okay, we have to sum the column first. Please take note of that. You need to sum the column first. And in summing the column, you must include this other one too. You include this other one too. Not just only this, not just only the 3, you must include the other one. But we are dealing with these 3, but in summing the column, you must sum up everything in that column. Everything in that column. Okay, so our matrix A will now become, 240 over the total of each column. 120 over the total of each column, then 120 over the total of each column. You see, we are not including this one. We are only including the sectors, okay? Now, for this one is 180 over the total of each column, 360. 36 over the total of each column, 72 over the total of its column. And this one, 144 over the total of its column, 48 over the total of its column, and 48 over the total of its column. You see, we are only using the total of each of the column. All right, that is our Leontief matrix. Please make sure you know how to get out your Leontief matrix. If you miss this one, you miss the other one we want to do. Okay, so please know how to get out your Leontief matrix. Okay, so after getting out Leontief matrix, this can be reduced to give us this. This Leontief matrix is simply 5 over 2 when you divide it, 1 over 2, 3 over 10. This is 1 over 5. This is 1 over 10. This is 1 over 10. Okay, and this is 1 over 5. This is 1 over 5, and this 1 over 10. Okay, that is our Leontief matrix. Now we need the coefficient matrix. The coefficient matrix is I minus A. That is the coefficient matrix. So that means we are going to have the identity, minus this our A. The identity minus A. The identity minus A. The identity minus A. Okay, that's what we need to get. That's our coefficient matrix. Okay, so that will give us 3 over 5 minus 1 over 5 minus 1 over 5 minus 1 over 2, 9 over 10 minus 1 over 5 minus 3 over 10 minus 1 over 10 and 9 over 10. Okay, that is our coefficient matrix. That is our coefficient matrix. Okay, now after finding our coefficient matrix, don't forget, in order to find our x, is our coefficient matrix multiplied by our x. This is the x we're looking for, equals to d. This d is not the old demand, it's the new demand, because we are finding the production for the new demand. We want to find what we are supposed to produce when we have the new external demand, when the demand changes to this. When the demand changes to this. Okay, so in order to find that, our x now become this inverse multiplied by d, which is our new demand, multiplied by our new demand. Okay, all right, so that means we need to find the inverse of this one. That is the inverse of this. The inverse of this. We need to find the inverse of this. So we are using the inverse method to find the inverse of this. All right, you can also use, don't forget, you can also use the fact that you can put this side by side with your d, and then you reduce the matrix, and then you'll be able to get your x. But now we are using the inverse method. Okay, so when you are asked to use the inverse method, this is the way to go. Okay, so we have this. So in order to find the inverse of this, we need to put this matrix side by side with an identity matrix. Okay, we need to put it side by side with an identity matrix. So I'm going to have now, so finding the inverse of A minus I minus A. So that means I need to put I minus A side by side with D. No, not with D, with an identity. Not with D. We are not going through that one. We're going through the inverse one. Okay, side by side with inverse. Side by side with inverse. So I'm going to write this and put it side by side with my inverse. Okay, that means it is 3, not negative. supposed to be 3 over 5 minus 1 over 2 minus 3 over 10 minus 1 over 5, 9 over 10 minus 1 over 10 minus 1 over 5 minus 1 over 5 and then 9 over 10. So I'm putting this side by side with my inverse 1 0 0 0 1 0 0 0 1. I'm putting it side by side with my inverse. Okay, so I need to now perform roll operation on this. I need to perform roll operation on this. What am I doing? I'm going to change this one into a 1. I'm going to change this to 0 to 0. I'm going to change this into a 1 to 0 to 0. I'm going to change this into a 1 to 0 to 0. Okay, as soon as I'm able to do that to reduce this one into an identity, reduce this by performing row operation to an identity, whatever I have there will now be my I minus A inverse. Whatever I have there will now be my I minus A inverse. So you need to reduce this into an identity. Then whatever you have there is your inverse of this one. So please, if you have not watched the previous video where we reduce that, please make sure you watch that. Okay, so in performing that, we now get this identity matrix. Please make sure that you are able to reduce it. So we get this identity matrix. So that we get this inverse matrix. So now this inverse of that, after reducing that, we now become 395 over 154, 255 over 154, 80 over 77, 50 over 77, 120 over 77, 30 over 77, then 5 over 7, 5 over 7, and 10 over 7. Okay, that is our I minus A inverse. So the next thing to do is to multiply I minus A inverse. So our X, which is the production, the new production we need to have, or what we need to produce now, is now this one. Don't forget it is I minus A inverse multiplied by D, which will become what we have there, 35 over 154, 255 over 154, 80 over 77, 50 over 77, 120 over 77, 30 over 77, 5 over 7, 5 over 7, 10 over 7, then multiply by our D. What is our D? Don't forget the new D. Multiply by the new D, which is 77, 154, and 231. 77, 154, 231. So we are multiplying these together. And if you multiply this row multiplied by this column, this row again multiplied by this column, this row again multiplied by this column. This is 3 by 3. This is 3 by 2, or by 1 rather, 3 by 1. If you multiply the two together, the answer we are going to be getting will be 3 by 1. Okay, 3 by 1. Okay, so if we multiply this row multiplied by this row, we are going to be getting 1385 divided by 2. If you multiply this row by this column, you are going to be getting 380. This row by this column, we are going to be getting 495. Okay. All right. This is equals to this, which is also the same thing as 692.5. 692.5, yes. So we have this and then we have this. Okay, so please take note when you are given a question like this, the first thing you need to do is to bring out your Leontief matrix, and Leontief matrix is gotten by dividing each of these with the sum, the total in the columns. This by its total, this by its total, this by total, and then the second one like that, also like this. So this is now the Leontief matrix. And then you need to find the coefficient matrix by taking it away from identity, not taking identity from it, no. You take it away from, not like this, no. It is, you take the Leontief matrix from identity. Okay, so you get that, and then you find the inverse of that, and then you multiply it by the new D. You find the inverse of that, and then you multiply it by the new D, and then you get the new production we are supposed to produce. And you now see the new production is 9692.5. The old production, actually this sum we get here, let me bring back, this sum we get there is the old production when the external demand is given as this. So this is our old X. This is our old X, is our old production, 600, 360, 480. That is our old production. This is our old production. But when the external, with this external demand, that means this production is with this external demand. But when the external demand changes to 77, 154, 231, we need a new production. And the new production is what we got here. What we got there. So this changes to this. That is for sector 1, for sector 2, for sector 3. So you see they all increases. They all increase. Okay, they all increase. All right, please ensure that you know how to do this. In getting your inverse, you need to find the inverse by putting the matrix side by side with an identity matrix, so that you now reduce it into an identity matrix, and automatically this will be the inverse. All right, ensure that you understand. Please ensure you understand.